Hello, I'm Eric Spellman. This is Yunje. We not on the slide, but we also need to acknowledge some of our colleagues. I'm going to miss some here. Kurt Schellhaas, Yanan Chin, Jacob Wasserman, Jennings Anderson. I don't see him here, but for sure. And then our Overture colleagues and the USGS. We're here to talk about building heights. We're going to talk about, yay, all right, building heights. And we're specifically about tagging OSM buildings and other building footprints with a height. I should also just mention this is my first state of the map. This is fantastic. It's been a great community, super awesome. I'm so glad I got to be here. I made my first OSM edits maybe 2 weeks ago, and I'm liking it. Raise your hand if you guys have gotten the Overture pitch, gotten the Overture spiel. All right, some folks know Overture. All right, I'll be just very brief. Overture is an open maps collaboration, and it's kind of, in this setting, it's a repository for us to disseminate open data. We're going to be hoping to talk with some of you, either in the questions or afterwards, about, okay, now that data is released with a nice license into Overture, how can we get that into OpenStreetMap? So that's kind of my goal as a result of in this meeting. Okay, building heights. So why are we talking about building heights? That's going to be the first thing. So why are we focusing on building heights? What are they good for? Second thing is, where are we talking about here? How many building heights? Where are they in the world? What are we going to be processing? Next, we're going to talk about how do we do it, right? What are the inputs, the outputs? What's the process? Then we're going to talk about how are we confident in the results? You know, this is a machine this is an algorithm, these are machine generated results. What have we done to build confidence in them and improve ourselves? And finally, as a result of that process, we found issues, as there always will be. How are we working to improve those? What are we looking to do in the future? And then finally, again, this idea, now that they're out there and published, how can we bring them into OpenStreetMap? Okay, so first up, we're going to talk about why are we doing this? Really, our initial use case going into this was visualization. So the 2.5D, 3D visualizations of maps. I point to the figure on the right. The top is, I guess this is as of April, looking at Boston with the buildings that are tagged with building heights in OpenStreetMap. This includes both kind of a physical height in meters, feet, inches, what have you, as well as floors multiplied by a reasonable amount. And the bottom is the result after our tagging has been run on the area. So it's, it's a big visualization win, the more of these buildings that you can tag. There's also other analysis stuff that kind of we've been learning about as a result of this. Just internally, there have been a lot of excitement about finding GPS canyons, places in the city where your GPS is not going to be reliable because you're in an urban canyon. Just occurring to me in this conference, chatting with people, shade. I didn't realize all of the importance. I live in Florida between the months of April and October. I should be aware of shade being important, but I wasn't aware of that being such a purpose of analysis. Having building heights helps with that analysis. And just in general, this data that we're using is open, it's out there, but it's terabytes of point clouds, or if you go to, say, Planetary Computer, it's slightly more digested in the form of giant rasters, elevation rasters. This is transforming it and enabling it in a format that is accessible to other kinds of analyses, because it's just a tag on a building now. Okay, about 20% of US buildings in OSM have height tags. We want to get that number way up. Globally, it's much, much lower. And then we're going to be using this 3-depth Lidar from the USGS, the US Geological Survey. This is a program they run. They partner with local community, with local GIS departments, with states, and they kind of provide guidance. They provide quality, kind of specs, and they provide a little bit of funding. But they're kind of a coordinator for a lot of these, where different vendors are going out and collecting different areas. So we're using that to estimate these building heights at scale. Then what do we do with them? We've got all this machine estimated data. Where does it go? We've figured it has value. We've proven to ourselves, we believe that it has value. We wanted to get it out there as quickly as possible for feedback, and then start to brainstorm ways of getting it back into OpenStreetMap. Overture was kind of the natural place for us to put this. So we can talk a little bit about that. Okay, what are we talking about here? Where is this? The upper right figures from the USGS, Lidar coverage. It is kind of patchwork, which relates to this idea that they are not a coordinated campaign, but kind of partnering with people and doing targets of opportunity. The color coding corresponds to what are called quality levels, which is a USGS spec, a little bit of which I've put in the bottom right. And this comes down to the fact that some states, some municipalities are willing to pay more for higher quality LiDAR, and other states, municipalities can get by with their use cases more economically. So you're going to get different kinds of collections in different areas, and USGS is trying to pull these together in a way that is kind of, it's rationalized a little bit. We are going to be focusing on all of the light greens and dark greens, that's QL1 and QL2, which is the vast majority of the US population and the buildings in the United States. So what have we done so far with all of this? In April, for the first Alpha Overture release, we processed 34,000 square kilometers and released tags on 6 million buildings. The next upcoming release, any day now, we processed cumulatively, this is not additional, cumulatively 87,000 square kilometers and cumulatively 16 million building heights. Where are these? I've listed some areas there, but I just want to point out, when we say Boston or Orlando, for instance, we don't mean municipal Boston. We mean one of these work units containing Boston. In the case of Boston, this is essentially half of Massachusetts, like eastern and central Massachusetts. So, Boston is Boston and its environs. And as I said, almost anything in this light green and dark green area on the map is game for the future. Okay, how does this process work? What are our inputs? For the inputs, we need building footprints. We get those from 3 places right now. The first and main source is OpenStreetMap. We go out and we get OpenStreetMap building footprints. We also get building footprints from the Esri community and from Microsoft machine learning generated footprints. These are conflated together. Those come in as well as LiDAR point clouds from the 3DEP program from USGS. What happens then? It goes together and out comes tagged building heights. So I'd like to point out here that you have an association between an OSM ID, if it was an OSM building, if it was a building from another source, you have a different ID. But in the case of OSM, for that OSM way ID, we have now put a height on it and it's tagged in Overture. So even though it's sitting out in Overture, technically, there's nothing stopping someone from moving that and now tagging the original OpenStreetMap building with that estimated height. How do we do this? Well, the figure on the right here shows kind of a little bit of a cartoon of it, or a figure from the process. The green are the footprints. They are kind of cookie cuttered out on the LiDAR. Some of these LiDAR, the point clouds are classified. This is done by the vendor. Sometimes it's not. Sometimes the classifications are good. Sometimes the point classifications are not. But when they're good, at a point-by-point level, that point says, hey, I belong to a building. Hey, I belong to vegetation. Hey, I belong to the ground. Hey, I belong to some other point class. Given that, we can filter. So in that case, we can only consider building heights as a part of that. We collect them within a building footprint. We run statistics on them, and that gives us a sort of altitude of the roof. In parallel with that, we estimate the height of the ground, and then of the terrain, take a difference. That's the building height that gets tagged. And then we do this at scale. As I said before, tens and tens of thousands of kilometers so far. Okay, and now I'm going to hand it over to Yunja, who will tell us why we actually believe that this is any good.
Yeah, so we have the building height predictions. We quite confident on that, but we still want to verify the accuracy. So we have the quality assurance strategies to verify these building height prediction accuracies. This strategy including 3 steps. The first step is sampling, second is annotating, the third one is validating. So for samplings, we do the stratified samplings, which means that we slice the target areas into Zoom 15 bin tile and use the number of buildings in the areas to determine this tile belongs to a higher, medium, or low density area. And then we evenly choose sample data from area in each density. So that's sampling. And then once we get the samples data ready, we do the annotating. We use a control point method to do the annotation. We have our human analyst to find the highest points. If you look at the top right pictures, we find the highest points of the building in oblique air imagery and make the annotations. So once we finish the annotation, we do annotation for each sample building actually. So once we finish the annotations, we collect the annotation result and move on to the validating steps. On the validating steps, we calculate the error between the height of the triangulated points and the Lidar height predictions. And that's the 3 steps of our QA strategies. So we have to apply these QA strategy on each work unit because each work unit actually collected by different vendors. So we apply the strategy independently on each one. And by far, we check almost 10K buildings. And you can see this is the picture, the chart on the top, on the bottom right is the distribution of the errors. And it turns out the majority of the building has less than, or the building height prediction has less than 1 meter's errors. We think we have a quite good catch of our work, but it doesn't mean it's perfect. Because during working on the building height prediction, we did encounter a lot of challenges. For example, the noisy source of ground heights, the point clouds without classification, misalignments, new buildings. We do have improvement strategy for each of these challenge. For example, the point cloud without classification. That means in a number of area of the point clouds, there's no classification between the building object and the non-building object. So currently we're working on our own classification methods and combining with the approach using the last return point of Lidar. Also the noisy source of ground height. Some buildings, they might sit on the elevated terrains, the Lidar height prediction comes out with a huge number. So we're working on to get estimation from the point cloud of the terrain, so we can get the ground height. With that, we can get more accurate building height. Moving on, we will continue our collaboration with Overture partners. For example, using the Microsoft Height Estimate from imagery, and also using higher level of detail models from other partners to improve the building height predictions. And currently our work only within US. We plan to expand that beyond US. We will also work on the rooftop prediction and the building part prediction. So in that way, we can differentiate the height of the buildings and the height of the part on the buildings better. And the data currently sitting in Overture release, but we always welcome any support to putting these back to OSMs. And we already connect to the Rapid team to see if we can provide a more convenient way to having the building height estimate tag onto Rapid, and then provide a more convenient way for user to putting these back to OSM. Thank you.
Did you publish the scripts you used? Is your process open?
It is not yet open. So that is a result of, this is sort of a target of opportunity sort of thing. We very much want to make it open, and even better, we want to make it where people can make it better for us, right? So that it helps everybody.
You've done script like that, I've done scripts like that.
Here. No, that is definitely a goal. We did not list it here. It is purely a function of, we just haven't done it yet.
And the results of the case of the building, that data is open?
That is out there right now. Overture Maps Foundation, the April release is out there with 6 million buildings, and the next release is coming soon. We have time for one more question.
How does the system handle, say, a building that's like 1 or 2 stories for most of it, but there's like a clock tower attached to it that's 8 stories tall.
So we deliberately tried to follow the OpenStreetMap spec here. If you go onto the wiki, OpenStreetMap says you take the highest point. This is not going to be visually ideal, and we recognize that when you extrude this footprint all the way up to the clock tower. There are ways of handling this in OSM with building parts, and that's what Yunja was referring to in our hope, I think, of segmenting that. Haven't done it yet.
Got it.